Hello, welcome back to BlenderSushi Live Noding. This video is gonna be really short and simple. It's basically there is a new update for Sverchok on Skinner node. Skinner node is one node that enable you to use a skin modifier inside Sverchok. So the way I usually work with a skin modifier in Blender is like if I start with a cube like this or any kind of mesh, I can just go to edit mode and then merge all to center, and then I start to control clicking and making branch or whatever. So this is how I'm usually doing using the skin modifier, and then just add a skin. We'll turn the edge into skin, and now we can sort of do that inside Sverchok, and even more we actually can do the scaling of the skin. So you can make it a thicker or thinner as you please, and yeah, and that's actually just being added the radius of each vertices skin. Okay, so if we go inside Sverchok, turn on Sverchok, and then let's say we are creating a line and use a viewer draw. We know that we're gonna get lines. I'm gonna save this real quick. Sverchok Skinner MK2, and if we are using the skin mesher, it's called, we're gonna get a solid object if we turn on the live modifier. Okay, we know that this is already possible previously, but the control over the radius is now a little bit more robust, even though this one's still like a beta node. So, but it's good to test it right now. If we use like a random number generator and set it to float, plug it into the radius, and let's see, we have to be careful here. Like we need to know the number of the vertices, because the radius itself, it's 4 of the radius here. So if we tell it, okay, Sverchok, generate a random value for each vertices, the number of vertices need to match this random number. So that's the idea. We're just gonna use the same integer number for both. Okay, so that's really nice feature actually, and you can do a lot even with just that, and then you just need to experiment. Currently the number is random if you are using random number generator, but you can use either like perhaps the noise, vector noise. Let's say if we plug in the vertices on that guy, and then with the noise we need to separate it into 3 values, and then just plug it in into the radius, we're gonna get that kind of result. That's kind of that's what noise generate actually. Sometimes you do get like a minus, but I think minus, it's kind of being floored to 0. So you see, this kind of structure is something that you can create previously if you're actually using Python, but it's now becoming so easy to create because of this skin mesher and then the radius control. Probably one thing that's I like to request is maybe to make it shade smooth, or maybe we need to do it right here, but that's okay, we can always do that ourselves. With the noise, if it goes minus, maybe we can just use map range and kind of control the value a little bit more. Oh, okay, so we can actually go over 1. So that's looking much better. Yeah, I think this is a really nice feature for Sverchok, and you can actually start to design like a, if you're like designing a character or insects kind of generator. Imagine you're making the body, and you're making like the arm. Or if this is spider, I think spider has 8. I don't know. If I have to draw it properly, maybe spider. Maybe it's a bit more like that, or maybe just other kind of creature. Actually, any kind of creature you can kind of make like a like a cage using this kind of method. Just provide the edge depending on how many segments, and then start thinking about the radius, and then you can kind of starting build up the model like this. So this is still something that I always want to do this, but not yet. Maybe with this things will be much easier. So we can control the stepping, of course. We just need to control like the age, like for that's how long is that segment, and then the next segment and the next segment. Maybe I need to kind of worry about the ratio, and then once we get that, we can simply build kind of like a simple basic form of all kind of creature. Yeah, I think that's definitely worth trying. Let me try if I kind of offset the point here. Vector math. Oh, vector math is now an MK2. Vector E. You can get that kind of effect. It's really nice. Stepping this guy. And see, this one is, we are just using like lines, but imagine if it's not lines. Maybe if we randomize the line, randomize input vertices here, and we start to get some cool effect really easily. Okay, so that's just a quick look at the Skin Mesher node update. It's still like a beta, like the developer said. So if you have any feedbacks, you go to Sverchok Github and then let them know if there is like a kind of bugs or any kind of feedback. So I really like this addition. I'm gonna have a bit of study first, and then yeah, we're gonna create something interesting with this. Maybe 3 kind of design. I don't know if you, even if you actually use the sapling. Oh, actually I'm upside down. So sapling generate this. This thing is actually a curve, but yeah, with this with structure like tree, you kind of need to have a think a little bit how you want to generate the the number pattern for the segment. I think you don't just plug it in the skin, or maybe you can, you know, like if you convert to mesh, and then you just skin it, and edit stroke. What is this? This is a mesh, right? Edit mode, and then mark skin. So yeah, of course you get this kind of tree, but for each one of the branches or the segment, you want to control the thickness a little bit better, and for that you need to make sure that you know how many points this one has, and then is it getting smaller to the top, and what's controlling this the original stem. But this is interesting, and because if you can generate this inside Sverchok, you can control everything using nodes. So that's basically kind of something that's really exciting for me, this ability to do this inside a node. Okay, so yeah, that's pretty much it for this live noding. Just a really quick one. If you have any comment, suggestion, let me know, and then I'll see you in the next video. Thank you. Bye.